we're going to talk a little bit about inverse operations and equations. So some of this may or may not seem basic, but the idea of an inverse and inverse operations that also can be applied to functions later on is a concept that is extremely important in math. And it's a concept that if you have a good feel for it and understanding for it, it's something that you'll be able to apply over and over and over. So we're going to start with that, and then we're going to talk a little bit about equations. And those two things, if you have a good concept understanding of that gives you a good basis on where to start with solving equations. So basically, what an inverse is, people think of it as opposite. It's the opposite of something. Well, it's the opposite in some ways, but it's not the opposite in the same way that we might say something like black is the opposite of white or something like that. It's more like the way it's used in mathematics when we talk about the inverse or an inverse operation is it's talking about order, the reverse order. So it would be more like the inverse of walking outside a door would be coming back and walking in. So we're talking about direction would be one way of thinking of it. But when we talk about mathematics, if we take something like 6 plus 7, so we're start with 6, and then we add 7. The way we get back to our original part right here, which is 6, is to undo that operation. So this is -7 or -7. That's the inverse, or it's the opposite, right? I mean, it's the opposite operation, but it's the opposite of +7. And so when you apply the inverse, what it does is it gets you back to where you started. So when you apply the inverse, you go back to the start. Okay, so we're going to be able to use that when we solve equations. Now, the other concept is the concept of equality, or there's a property of equality. And basically what that says is when we have this symbol right here, the equal sign, it means the left side is equal to the right side. And basically it says that if you add the same, well, instead of saying add, let's just make it more general. If you do the exact same thing to both sides of the equation, it stays balanced. Okay, those two basic concepts are the critical ideas and concepts that go into solving equations. Now, the rest of it is just moving things around and using these as a guideline to kind of peel away extra stuff. So if we're solving an equation like this, 2 times x plus 3 equals 13. Solving it means getting x all by itself, where we find out what x is equal to, and whatever x is equal to, if we plug it back in here, it will make the equation balanced. That's what being a solution is when you replace that value with that value x with the solution, it makes the equation true. So what do? We always remember that we need to keep it balanced. So no matter what it is we do to one side of the equation, we do the exact same thing to the other. we can do anything we want. We can multiply both sides, we can divide both sides, we can subtract, anything we want. But we want to think about it strategically. The whole idea is we want to reduce the number of items, I guess you could say, on the same side as the variable. And one of the easiest ways to do that is to think about the order of operations. You can use PEMDAS to help you remember that. But the main ones that we're going to be concerned with at the beginning are these four right here. Okay? Multiplication and division. Now I'm putting them not next to each other, but on top because they go together. So that comes first, and then adding and subtracting. So the easiest way to do this is to go in reverse order. So we're going to subtract 3 from both sides, which is the opposite order we would normally go. Normally we would multiply both sides, and we get 2x equals 10. Now we have, so each time we take a step, ideally we should be getting a simpler equation. So now we have 2 times x equals 10. Now the inverse of this is multiplication, so the inverse of multiplication is division. So we divide, and we end up with x equals 5. So the first thing we do is we look at plus 3, use the inverse operation, positive 3 minus 3, that gives us a 0. 13 minus 3 gives you 10. We bring down the 2, and 2x. Now we divide by 2, and the 2 doesn't vanish. Okay, 2 divided by 2 turns into 1. So we end up with 1x, but 1x is actually the same as x. So we can just, this is kind of a shortcut, and we end up with x equals 5. Okay. Why is this not?